Hello. Today I'll discuss what we call skipping reentries, where a spacecraft skips off Earth's atmosphere to extend the reentry and reduce the heat load on the spacecraft. On December 11th, 2022, the Orion spacecraft used this reentry maneuver at the end of the Artemis 1 mission to the Moon. If you've ever skipped a rock off the surface of a lake, you have an intuitive feel for how this works. For this to occur, the spacecraft must have lift. Even a rock has lift if the speed is high, the angle of arrival is shallow, and the density of the liquid or gas is higher below than above it. The danger of using skipping for arriving spacecraft is twofold. First, if the lift is too high, the spacecraft will skip into higher orbits several times, taking much longer to lose momentum for reentry. Second, if the lift is too low, the spacecraft will immediately re-enter the atmosphere and burn up. You must know the density of the atmosphere and the resulting lift before attempting this. Therefore, it requires a good model for atmospheric density to plan such a maneuver. This software uses the NRL MSISE00 atmospheric density model developed by the US Naval Research Laboratory. Now, open the skipping example project file. Note that this spacecraft skips 7 times before its final reentry. Note also that the distance between skips gets shorter each time as the momentum is used up by drag in the atmosphere. If not for drag, the spacecraft would continue to skip forever. Go to the left side control panel and look at the drag and lift coefficients for the spacecraft. Note that the lift coefficient is 5, while the drag coefficient is 10. Both lift and drag are proportional to the density of the air and the square of the relative velocity between the spacecraft and air. Let's see what happens when we increase the lift coefficient to 50. Do that now, then press the Tab key and recalculate the orbit. Next, increase the simulation time span by 3 hours and recalculate the orbit again. Note that the final reentry still has not occurred. Next, decrease the drag coefficient to 2, and then press the Tab key and recalculate the orbit. Note that the spacecraft appears to be days away from final reentry. Now, increase the simulation time span by 1 day, and then press the Tab key and recalculate the orbit again. Run the simulation. You should now understand why it's imperative that you do these calculations accurately. As always, thank you for watching this video. If you find it useful, please give it a like and consider subscribing to the channel. We will be producing new content in the future, so if you want to be notified when new content is added, click on the notification bell. We need your feedback, so leave comments in the comments section. Goodbye.